Good evening. Welcome to our TI Technology webinar hosted by Texas Instruments. This is the third in the series of How To with your TI-84 graphing calculator. My name is Ruth Casey, and I'll be the moderator for the event. We will be using the WebEx chat panel to share comments or ask questions. When you send a chat, please select Everyone from the drop-down menu. Let's try it now. We invite you to select Everyone and share your name and location. Use the chat panel, select Everyone, share your name and location. Thank you. Remember, throughout the evening, use chat panel, not the evening, just this event. Use the chat panel and select Everyone. If you choose all attendees, panelists won't see it. They won't be able to answer your questions or share your comments. As a reminder, the session is being recorded and will be available for viewing or reviewing the presentation. If you experience any audio or video issues that you can't resolve, or your computer won't resolve for you, please feel free to watch the recording later. Just take a second here and look up and down the chat. See who all's greeting us tonight. Remember, choose Everyone from the chat panel. I'm so pleased to have outstanding educators with us tonight. So ready, set, go. John Lemaster and Stuart Moskowitz, unmute yourselves. Thank you so much for being here. Please say hi and tell us a little bit about yourselves.
Hi, I'm Stuart Moskowitz, and I recently retired from Humboldt State University up here on the Redwood coast of California. And it's great to be back again for part 3.
Hey, I'm John Lemaster. This is a virtual beach. I live in Fort Wayne, Indiana, where there's cornfields and soybean fields, so no beach. But I'm thrilled to be here. This is going to be a fun evening.
Thank you. Thank you, John and Stuart. Let's just go ahead and get started.
All right. Well, to give you just a little preview of what we are hoping to do, of what we're planning to do, I want to show you, use mathematics to see the real world by creating graphic designs. And we're going to learn some new features in the calculator that perhaps maybe you've looked at, but probably, perhaps not. Graph styles, the format menu, piecewise functions, graph databases, and we'll even look at how to use lists, not just in the statistical function of the calculator, but also using lists so that we can do more than 10 functions at a time. And John is going to also use mathematics to bring story problems to life, and his focus will be on parametric equations.
Okay, great, Stuart. Thank you. And so after the webinar, you'll get a link to the recording, which will enable you to view what we're sharing at a pace that's just right for you, as well as get a very detailed handout. So we think you'll enjoy this best if you don't try to follow along with your TI-84 tonight, as much as you'd really like to be tempted to do so. Later, once you play on your own with the recording, you'll be able to use functions and graphical databases to create designs. Another item on our list is using piecewise functions and lists in the y-equal editor, and then using parametric mode to create what we call silent movies. So I'll turn it over to Stuart, who has some great stuff to show you.
Thanks, John. I hope I can live up to that. So I'm going to go ahead and well, let's just dive right in. And the first thing I'm going to do here is I'm going to make sure that you know how to reach me. as John said, we have our handouts are available for you that you can review afterwards. Just in case there's any trouble getting the handouts, you please don't hesitate to write directly to me. There's my email. And any further questions, yes, we're going to go through this stuff pretty fast. And hopefully the handouts will help to clarify. But if not, now you've got a good way to reach me. So I'm going to share my screen. And let's see if I can pull this up quickly here. There it is. All right, I hope you can all see. This is the handout, and I want to sort of go back and forth between the handout itself and then show you a little bit about what it's doing. And I want to go over an assignment that I have used many times in a pre-calculus class instead of a final exam. If a student can draw a picture on their calculator, they have to have a good understanding of the functions that we've been studying in class. And I try to motivate them by encouraging them, if they have any interest in computer graphics, which most of them do. You can't be a graphic designer if you don't have an understanding of, of the functions. How do you draw a picture on a computer screen? You need to know, you got to know some algebra. So I encourage them to draw a picture, and it can be anything they want. And I give them this list of functions. Of course, it'll depend what point in the class you decide to use this. If you're teaching a beginning or intermediate algebra class, you might want to just keep it very, very simple. Just a linear function, maybe quadratics, and maybe nothing else. But again, that's up to you to decide. And one of the reasons I want you to have this handout in Word form rather than just a PDF, I'm going to give you both. But in Word form, you can edit as you like, and make it fit, make it customize it for your own class. And so here's what the assignment requires. They have to draw a picture, and I give them a certain score depending on how many different basic graphs that they use. They get more points if they use different families of functions. And then I give them even more points if they use some of these little tricks that we have, like integrating lists in so that they can get multiple graphs using just one equation. I give them extra points if they use graph styles, and I'll show you what that's all about. And then restricting the domain is a huge piece of this. And it can be done with the newer operating system. We have piecewise functions. But we don't even need to have piecewise functions to restrict the domain. So I want you to see a little bit of both ways. And then I want them to be able to save what they've done. And that's why we need to know what a graph database is. I give them choices for how to submit the assignment. They can just draw a hand-drawn sketch of what they've done on the calculator and make a list of all the functions in the y equals menu. That's one option. The second option I give them is to give me a printout of a screenshot and print out screenshots of their y equals menu and the window menu. To do that, they need to have the TI Connect software and a calculator to computer cable. I also give them the option of coming to see me during my office hours or after class, or at any point when they're ready to submit, and they show me what they've done on their calculator, and then they turn in a graph database. And by submitting the graph database, I have all the work that they've done. By the way, there's my email address again right there on the handout. So again, the handout gives a little more of an explanation about piecewise functions, and I'm not going to read this part to you. I encourage you to go back later and read through this a little bit more. I want to get straight to some examples where I will go through all this. So piecewise functions, but as I said, really more about restricting the domain is the most important aspect of this. Also using lists in the y equals editor, using graph styles. And if you notice here in this screenshot of the y equals menu, I'm actually going to, let's see if I can make this even just a little bit bigger for you right now. And that to the left of the y, to the left of the y equals, you can have, we can change the color, obviously if you're on a C or a CE. And you can also, in Y1, we can just have a line. In Y2, you can have a bold line. Y3, that icon says to shade everything above the line. Y4, you can shade everything below your function. Y5, you can put a little ball on the path of the line. Y6, you can have a little ball instead of the line. And then Y7 and Y8 are dot modes instead of connected modes. So these are the different graph styles that we have. And again, I'm going to show you all of these in a little more detail. But let me come back out again. I'll get to the graph databases right away. And so let's just get straight to the first example. I encourage them to make a logo. So I'm going to go ahead and move to my emulator here. And notice that I have nothing here in the Y equals menu. It's an empty screen. I'm going to go back to the home screen, and I'm going to go to the draw menu, the second function above program, excuse me. I'm going to scroll over.
Excuse me, Stuart. I'm not
Yes.
sure that we're seeing your emulator. I just want to double check. I'll look in the chat. I
Oh,
think we're still seeing your Word doc.
okay. Thank you. Thank
Sure.
you, Ruth. Yeah, don't let me get too far away here. Let's see if this is any better.
Perfect.
All right. Okay. Thank you
you.
for calling that up right away. So let me start that over, okay? Here I am, I'm on a blank screen. My Y equals menu is empty, and I'm going to go back to the home screen. I'm going to go to the draw menu, second draw. I'm going to scroll over to the stow submenu, and here we can store and recall pick files, and we can also store and recall graph databases. So I have already stored graph databases in here, and I'm going to recall graph database number 2. I can store 10 graph databases and 10 pick files and simply give them a number from 0 through 9. So I'm going to recall graph database 2. Done. That's all I get on the home screen. But what that has done is it has set up my mode menu. It has set up my format menu. It has set up my window settings, and it has also pasted all the equations into the Y equals menu. Now, we don't ever write piecewise functions by writing the word piecewise, but if you notice here, I'm in classic mode, okay? And I'll get back to that and explain a little bit, because let's just get to the punchline here. I'm going to press graph, and boom, there it is. In some ways, I like it better on the handheld instead of on the emulator because it's so fast using the Smart View. It's just too fast using Smart View. I see a question about does it change radians and degrees, and no, it does not. So if you are using any trig functions at all, you got to make sure that you go into mode and set that up by hand, and we'll look at that example in just a little bit. So what you've got here, I've got 4 pieces of rational functions right here to make the S. I've got 4 pieces of linear functions to make the M. And then I have the top half of an ellipse and the bottom half of an ellipse. And that's my whole thing. That's the end result. So let's go back to Y equals. And in fact, I want you to see, I'm going to go to mode and change it back to math print instead of classic so that you can see this a little bit. It's a little bit easier to read, but unfortunately in math print, it does not wrap around. And if the entry lines are long, and they frequently are with piecewise functions, it'll just go right off the screen and we can't see it all. So I find it's often better I often go back and forth. So notice that y1 is simply this rational function, -1 over x, when it's been shifted up 10 units. And here's the restriction using Boolean logic. X will only print between 4/10 and 3 7/10. Y2, there's another rational function. So do you see what the students, there's some really rich mathematics, because I won't tell you how many hours of trial and error I spent shifting these up and over and stretching them little by little to get everything to line up. And so, yes, you know, and sometimes I find my students will spend hours working on these, trying to get them to getting everything to match up. So here's y1 through y4, and we have the rational functions. I'm going to, let's see, I'm going to scroll down so that you can see y5. And notice in y5, we've got the linear function there, y6, y7, and y8. We've got linear functions. I could have, in fact, put all four of these into one function, one piecewise function. Notice that each of these piecewise functions only has one equation in it. I can have up to 5 when I am creating these. I will confess that many of these I did before I got the piecewise functionality. So I have modified these, and some have been modified more than others. I kind of like, in some ways, I like it even better. This helps it to see more of what's going on when we do it this way. Y9 is the top half of the ellipse, and there's Y10, the bottom half of the ellipse. And this would have been very easy to combine into one by putting the negative sign up with the in Y9, except I only have one graph style, and I wanted the top half to shade above, and I wanted the bottom half to shade below. So I had to split this into two. So this is my Stuart Moskowitz logo. And that's the first one. So let's go on. All right, I'm going to go back to the handout. And I want you to, you know, so again, so that you can see what I've done here is you will be able to download the graph database, but you don't need it. You have everything you need is right here, and it can be typed in directly just from these screenshots. But I'd certainly understand if you want to download the graph databases as well and just load them onto your calculator. I want to say just a little bit here. Notice this window settings I have here. This is kind of an odd X min and X max, but there's some logic to it. The distance between X min and X max is 26 4/10. And the reason it's 26 4/10 is because that gives me a trace step of 2/10. And it makes it much easier to manipulate when you have a nice increment here for the trace step. It also makes the halfway point of this ellipse, they actually meet when it's on, you know, because they will land on those rational endpoints. Otherwise, you end up getting gaps. It's much easier to close the gaps between the pieces when we do it this way. Okay. Notice that in format, I don't want the axes turned on. So this is a case where I turn off the axes. And the only reason I turn off the detect asymptotes is that it slows it way down. Of course, that's not an issue with the emulator, with the Smart View. But I typically tend to leave it off unless I'm graphing something that specifically needs it. So that's the first one. Let me show you another one that has a little bit of animation. And John's going to show you some much more sophisticated animation than this one. But so what I'm going to do here is go back to, you know, I'm going to go back here. I am going to go back to the home screen. I'm simply going to go recall graph database. And instead of going back into the menu, I want to, perhaps you have never done this before. The last thing I did was recall graph database 2. So I'm going to go up and I'm going to grab it, and then I'm just going to edit it. And I know that this is, I believe it is graph database 6. I might have to do this twice here. There's recall graph database 6, and I'm going to press there, and there it is. And there's my little roller coaster on going up and down. And of course, I was in radian mode. If I had been in degree mode, that would have looked very different. So here I have 4 concentric circles to make the sun. I have 2 parabolas to make a little bird, and 2 sine curves. And so let's go back to y equals so you can see all of this. Now, I put the top half of all 4 circles into one equation using the list. So notice here the curly brackets in y1. So because you can't see the whole thing, all this scrolling off the screen, I am going to go back to classic mode so that you can see everything at once. Okay, you can see what now we get the wraparound. Okay, and so here we've got the circle, the top half of the circle, but there's actually 4 of them. So it's going to graph 4 minus x plus 10 squared plus 5. It's going to graph 2 minus x plus 10 squared. It's going to graph 1 and the 4/10, all 4 of them. And then we get the bottom half as well. And as I said, I could have done, well, no, with that negative out in front, I want to have them on separate ones. Now, I could have done a separate list. You can do a plus or minus by putting just 1 common negative 1 in curly brackets. But because I have four elements in a list, if I'm going to have another list in this equation, it has to also have 4 elements. I do have some restrictions there. My piecewise function, which is the bird, okay, the 2 parabolas. So in other words, this piecewise here, -8 times x minus, and here is the horizontal shift, and then we have the vertical shift, and then we also have in the restriction, since the 2 different parabolas, which are shifted horizontally from each other, so that's the 6 and the 6.8. And then they each have a different restricted domain. So x for the first parabola, x will go from 5.6 to 6.4. And then for the second parabola, which has been shifted over, it'll use the second element of each of these lists. And notice here in y3, I have a sine curve that has been dropped 3 units, and I'm shading below it. And then in y5, I have the same sine curve, but it's only shifted 2.5. And there's the little ball. So if you want to see this again, I'll go back to graph. And it happens pretty quickly, but there it is. And I'm going to let this run through because I do want to show you one thing here. Oh, that was kind of cool. I'd like to watch it again. And I can go to y equals and see there. If I go back to graph, I get the finished product. If you want to see the animation again, if you want to actually see it come up on the screen, go back to y equals and just trick your calculator. I'm going to put the cursor on top of the 4, and I'm just going to type a 4 on top of it. Just make make it, make some kind of a change, even if it's not a change. But by typing a 4 on top of the 4, I now can get it to plot again. Oh, look at that. It only gave me that last part. I learn things as well all the time. So at least we got to see that little piece. Okay, so that's the second example. I'm going to go back to the handout and show you that I put a third example in here, the spider for the 84 plus. Not everybody has a color calculator, and so I want you to see some of the differences. Notice that for the on the 84 plus, the distance from x min to x max is 18.8 because we have a different number of pixels. It gives me a resolution of 1. There's actually 94 trace steps from the left-hand boundary to the right-hand. If you want more information about that, again, shoot me an email. We can have a good discussion about that as well. And so let's see. Let me go back, and I'll show you what this spider looks like. So I'm going to go in Smart View. I'm going to switch over to the 84 plus. And again, I got an empty screen. And so I'm now going to go to recall graph date. Whoops, no, I don't want to do it there. I want to do it from the home screen. I'm going to go to the draw menu, stow. I'm going to recall graph database 3, press enter. All I get is the word done, but now it has dumped all of these equations into the y equals editor, and I get a spider dropping into a bowl. This was done by one of my students. Definitely got an A for this one. And because I don't have the ability to do a piecewise function, I want you to see the y equals menu a little bit better as to what's going on here. I'm in classic mode, and in fact, I'm going to change this one to the math print because I think you'll get a better sense of what's going on. Let's go back here. So I have a parabola, and I'm dividing by this Boolean test. X has to be greater than or equal to -5 and less than or equal to 5. The only place on a TI-84, be it black and white or color, where you can actually write -5 is less than or equal to X is less than or equal to +5 is when you're actually doing a piecewise function. And I'm not doing a piecewise function here. What I'm doing is I've got the parabola and I'm dividing by this Boolean test. Now, if the test is, if X is between -5 and 5, then this denominator will return a 1. If X is below -5 or above 5, then this denominator will be 0. And so if I divide by 1, I get the numerator. If I divide by 0, I get nothing. It's undefined. And so in fact, if I go back to graph and then press trace, you can see here I am on that first parabola. If I trace back here to where X is going to be less than -5, it keeps going. You can see the X values here, but the Y's are blank because we're dividing by 0. Not allowed to do that. So is there anything else in particular on here? Again, Y4, I'm in math print mode. Here I'm using this plus or minus 1 in order to get both the top and the bottom half in one as one equation. So this is the equivalent of saying plus or minus this the 4 minus x squared. And that's the end of it. Notice here in the numerator, I actually have two different equations, and that's in a list. Here, let me make this, I'm going to go back to classic because it's the pixelated, the 84 has it's a little harder to read. And when it's in math print mode, it's a little bit too small to see it better. But I want you to see what I've got here. I think that was Y5. Yeah, or no, Y4. And now it wraps around. No, it was Y6 that I wanted to show you. No, oops, I'm sorry, Y5. Notice that I have inside the curly brackets, I have one parabola, comma, and then a second parabola. So there's actually two parabolas in Y5. And then I'm dividing it by the restriction that X has to be bigger than -2.6 and smaller than 2.6. So there's going to be two parabolas, and I use the lists. And notice I can put the whole equation into, as an element of a list. Pretty powerful feature, very powerful feature. So that's what I wanted to make sure you saw there. Now, there's a lot of information here. I certainly don't expect you to remember all of this at once. That's why you have a detailed handout, and you also have a chance to reach me. And I'm going to show you one more thing before I turn it over to John. I don't have it in the handout because it really is more advanced than what we're ready for in this 1 hour. But I want you to see the power. I mean, John's going to give you some wonderful stuff with parametrics. When I'm doing these logos, these designs in function mode, I can only go from left to right. But in parametric mode, And so I'm going to go back and I'm just going to show you one more real quick. I'm going to recall graph database 7. No, I'm not going to do it on the black and white one. I'm not going to do it on the black and white one. I'm going to go back to the color one. I'm going to go back to the home screen, and I'm going to just go up, up. There's recall graph database 6. Here's graph database 7. Let's recall it. And I'm going to show you but here, that question that came up, uh-oh, those sure don't look like stars, do they? So let's go to mode. Let's change radians to degrees. I'll press graph again. And I could not, and I have to have the parametrics are the only way I can make something like this happen. And so yes, there are actually, for those stars, you can see how much time went into this. Those big, bold blue lines require a lot of thinner lines. And yes, even in, here's what the stars look like. So there's that to get 50 stars, I have to have 50 elements in that list. So I'm going to stop there. This is think of this as sort of your, the final at the very end. Start out in function mode. And yeah, please don't hesitate. Any questions that come up, and I'm delighted to be able to turn it over to John because he's got even better stuff to show. So let's pass the ball over to John. I'm going to stop sharing my screen.
Thank you, Stuart. That is amazing. Just amazing. And we have so a few questions in the chat. If you take a look at that.
I'm sure I'm getting there. I'm trying to get back to it. There we go. Thank you, Ruth.
And
okay.
One of the questions I can answer too, and it was a question about where did the semicolon come from. And I'm going to share that if I'm in math print and I do math and then I'm going to just cheat. I'm going to go all the way by pressing up to the down, and I'm going to get to the piecewise. And I'm on the home screen, and if I put in 2, there's the semicolon, it comes in, and then you'd have your choices here to put in your x and maybe x squared. You can then ask for your conditions here by going to second test, and conditions are in this. So this won't work on the lower model calculator, but in the 84 CE, you have these compound inequalities and more. So you've got lots of choices there, and you can actually write it the way it would be in the textbook, only with this function. And what I'd like to do is point out, suppose I filled this in, and it isn't filled in, but just to give you an example, if I have this already here and I hit enter, it's not going to like it. I know we don't like it because it's not done. All right. Okay, I am going to really screw it up and just put this in. It may not even like that. Okay, it did. All right, so this isn't meaningful, but you get the idea that if I wanted to type in, I could put it right here on the home screen, and then I can go into my y equal, and I can hit second enter, and it's a lot easier to type one of these on the home screen if you have 7 pieces of it because it's squished up and stuff. So it can be a little easier that way. Now the other question was a little longer. I'm going to let you, Stuart, you read that. This is I've got a few, like 20 more minutes of the webinar to show you some things, and we'll have time for questions. So that was a great question. The other thing that is cool is even though I'm in radian mode, if I'm in a program like you had showed, and this is a kind of a cute thing, well, I may not get into a program, but you can, if I want to do cosine of t, okay, t, I'm in, I think you had a cosine of t in there. Um, this will be in radians, but if I go to second angle, this is a cute little way to fix that flag. Now, whether I'm in radians or degrees, t will be understood to be in degrees. So if I've got constraints of t written in degrees, I can always just one more little step. So I wanted to share that cute thing because Stuart and I had fun making that flag. Oh, I didn't make it. I just fun playing with the flag. And now, I mentioned to you that keep your questions coming. It's very fun to see the activity on the chat. Um, I mentioned to you that you'll get a handout and a recording, but I also am just going to throw right in the chat now a link that you don't need to go there now. If you can, of course, I don't blame you if you did, but I just want to show you what will happen in that link, and that is you'll get to a page where my handout that I'm going to share with you is already uploaded, and a few more descriptions of things and resources. But what I wanted to show you is this cute little T that helps me understand what's in a graphical database. And T for TI, or Texas Instruments, is a neat memory trick because you've got what you've got in here is the Y equal graph styles and selection choices. The window, the format menu is settings, and only out of the mode these three bullets, which deal with graphing. So not degrees or not other things, not auto or anything like that. But all of this is stored in a graph database. And if you look at this T, it's a cute way to remember that. Now let's have a little cute fun with going to this handout. You'll see this handout in what will be mailed to you and also on the website. And I have had fun with making little silent movies by using the idea of, okay, this, you know, you've seen this where one car is traveling at one speed, another car is slower, but it has a head start, and in this is now the tortoise and the hare, so it's a very classical story. In fact, I probably are not going to surprise anyone with the classical ending. And if I were to ask my class, well, who wins, and they would just yep, you're right, Sam. The hair, so it's not like we're going to care about the essentially the, the ending, but let's mathematize using parametric mode this to create a movie situation of it. And so I made the tortoise named Sally and the hare named Harry. Now it's a fable, so I can pull this off in a fable, right? So it's um 40 miles per hour Harry is traveling, the hare. And so Harry has some equipment he's on, apparently. And Sally, the tortoise, is going only 1 6/10 miles per hour. So that's a little fast for a tortoise. I mean, it's like 2 feet per second, but okay, Sally, we get away with it because it's a fable, and Sally has maybe a skateboard. So nonetheless, there's a huge head start. Sally's 12 hours in a head start. So Sally plods along very steadily, and it's a 21-mile race. Who will win? Well, we already kind of know, but unless there's a surprise, here's how to create the silent movie. Now, before we get into the silent movie um, details, I'd like to show you the silent movie, and I have my y equal already stuff in it, but if I go to recall second draw, and I go to recall GDB1, if all goes well, when I press y equals something will change. Now, in fact, I'm going now into parametric mode. And so my mode is changed to parametric instead of function. And when you go to parametric, it's really, really important to not freak out if you've never been there before, because you're not in Kansas anymore. You're going to find that three things have changed. When you go to second trace, there's a lot less there. There's no intersection. When you go to window, there's three additional things involving T, and then there's your classical usual stuff. There's also no XRes for a reason. XRes is how to fix the resolution in function mode, because the resolution of the graph or the speed of the graph is controlled by Xmin and Xmax. This is really, really, really cool. Parametric mode lets you control the graphing speed independently of Xmin and Xmax. How? Through the T. This is going to control the Xmin and Xmax. And there's a third thing. So there was second calc, there's window, and then there's y equal. And here's what we've done. We've put in on two different lines. The tortoise is in x1, going 1 6/10 miles per hour, and t is going to give us in hours, and our speedy hare will be in x2. Now, when you look at what's happening, the increment of t means that for the same value of t, the x is going to climb, or actually go forward, at 40 units for every t, every 1 t, while the tortoise will only go 1 6/10. So things might be a lot faster. I've changed my window. So the window is going to have a few things to say that I'm going off to 24, and I put a marker at X scale for 21 to be where at the end of the race is. It's a 21-mile race. And I've given a little room after the finish line to 24. And now we'll see what these mean by pressing graph. So I press graph. Here goes, oh, I've used a style here. And wow, there she flies right by, and the hare wins. So it is natural now to ask new questions instead of who wins, and kind of see how did we set this up and what things mean. So two things here. Step one, and you'll get this handout. So it's really neat to make sure that this is not just parametric, but also simultaneous. So these three things out of the mode will change in a graphical database or be stored in. And simultaneous will be important for a movie to happen. We put in these in our y equal, and 4 in red is our height. I really just graphed this very steep line on on a horizontal. I plastered that right there on a horizontal. And 1.6 t, or 1 6/10 t, is on the line y equal 2. So these settings make a little more sense if we've seen what happened. That 21 was the marker for my X scale of the finish line. 24 was the ending of the window. Arbitrarily, I put on 10 as my Y max because I have 2 and 4 as my two race paths. And so that made sense, but that's arbitrary based on what you chose in Y2 and Y1 and Y2. And then here. So we wanted to see, I already knew a lot of how this would play out. So it's very important to practice, because how I would do this exactly on a calculator that's in my hand versus a computer is different, because the speed of this computer, the processor of this computer is what's moving these to DAW. And on the calculator, it's using a Z80 chip. So things will go slower on the calculator if you were just pressing this and did it on your calculator and then move to your emulator. Your emulator might surprise you, but wow, that's really fast, because it's not using the same engine. And so I did not show that graph style change here, but using graph style as the path will actually give it a little slower graph too. But the t-step affects how fast the movie's played. Yeah, so when I look at this in dot mode, for every now these are in the same, they're a half step apart. Remember, my t-step is a half. So for every half, the x moves really big for Sally, and it doesn't move very much for the tortoise. So if you were thinking of these two as vertical lines, if I had a delta x, or delta, yeah, a horizontal change makes a big vertical change. Here, the t, the same t change makes a huge difference in the spread of the dots. Now, when I explain to my students, I really don't go into these details. I just want to animate the movie. But I want you to say, well, why am I getting what I'm getting? And that is because, well, just imagine you are walking, you're an adult, and you're walking with a little toddler who's taking little bitty steps. Well, you're going to definitely, if you're walking at the same footsteps, you're going to go ahead of the toddler. So you're going to see that you would go much faster with bigger footsteps. So changing t-step now, this is in a tenth, I certainly have more lots. So what the calculator does connects these with lines. So it has more connections to make when the t-step is slower. Now, what I'm going to share with you is one of the things I like to do with my students is ask them new questions and say, well, what would you say, is curious about, what you might do? And feel free to throw anything in the chat here. We know who won. But yeah, that's exactly what I would say too. When do they meet? What's the and remember what their names are. I've got Harry the Hare and uh yes, that's Harry meets Sally. When did that happen? So that's really what I'm asking is if I can slow it down, can I actually, and let's do that in changing my t-step. Remember, the slower the movie, that means the smaller the t-step. And what I'd like to do then is turn to a student and say, who's got really good, um, eye coordination, hand reflexes. So they can get able to. You're going to press the enter button when you think Harry and Sally meet. And so you have to be careful. It's really fast. Remember, it's right before the mile marker. So here's the mile marker. And so the student will get up there and they'll press the enter button and bam! Oh my gosh, that's the first time it's ever happened. Okay, I probably am gotten lucky, but if I notice this is in the kind of vibrating phase, and so if I press enter, it'll continue. So most of the time, they're not as good as me, and they'll miss. And so I have other students do it. It was kind of a fluke. I think it was just a lucky night. I'm graced. But what I think is neat is that is a motivation for them to do the algebra. And so I can say, here's the distance that our slow little tortoise Harry is moving, miles per hour times hours. Here's the distance our friend Sally the hare is moving. Our equation setting together, it looks like 12 and a half. Remember, we had it at 15. So if I change my, okay, here we go. I'm going to change this to 12 and a half. Then I don't even have to have Jedi skills to graph this. And then it'll go and, oh, let's actually, if you ever want to pause something, you use enter. If you ever want to stop it and say, no, I don't want to do that, I'm going to move it and speed it up, you press on. And so on at let's go faster. Back to the ramming speed. That this will actually stop the action right at the time that they meet. So we have, and we have now new questions that might be worth, some students might be able to get. And so this is an optional extension of this. What mile marker did they meet? So when is that? And one of the easy ways is to just stick in 12.5 in these equations. Now, you can't solve this graphically by seeing when these intersect unless you do more with parametric, such as put, this is a way to make it a function grapher, put t in for x, and then your a function in for y3, and now you've got y3 as a function of t, but t is x, so you could do it that way, but there's no intersect button, right? So this does force some algebraic reasoning that we want as a goal. And how long did it take each to cross the finish line? So when you look at this this race is 12 hours and 31.5 minutes, and that means Harry was in the lead for, out of the 12 hours and 31.5 minutes, 90 seconds. The last 90 seconds of the race is when you wanted to not be in the concession stand or in the restroom. So it's a good thing we watched it. Now this handout would never be something we could cover in a 50-minute webinar. We are about ready to close, but I do want to point out there are some questions that or some other activities and other ways to do movies, and so this goes to 14 pages, so you can see all of these activities. Batman and the Joker, they're going toward each other instead of away from each other. And Alexander Hamilton and Aaron Burr, you know the ending, and we don't have a musical, it's a silent movie. So that's kind of the fun thing about this. And there's lots of stuff even for trig in there, the Berlin Wall or a spotlight, and that goes to calculus. Here's the roller coaster, lots of bus chase, cool stuff. So this handout will be coming to you, and there's our email, and this website that is in the chat is also got the same handout.
John, could you scroll
Yes.
to the place where yep, just a little bit further down,
Yeah.
right there. Show us where you clicked to take us to that treasure trove.
Oh yeah,
yes,
yeah.
that right there.
Right there.
It's
And
the
it's also up
magic
there,
door.
and it's in the
Yes.
chat too. So bingo,
Yes.
bango, bongo, and here you have it. And this is just almost a historical archive of everything that Stuart and I have done, and Ruth and you and I have done these things, and other folks there too. So lots of cool things. You can download things. I would recommend, if you have a zip, that you right-click things. And we were playing with this and found that oh, and here's a link to part 4. So please come to part 4. We have found that if it tells you, oh, it's not a secure document, maybe there's some security issues going on with other file formats other than PDF, and either using a different web browser or changing settings on the web browser, or just ask us and we'll email it to you. So we've got our contact information. Stuart, did you see, or Ruth, any questions in the chat? We have just a few minutes now to close that people want to have loose ends tied up.
There were some questions about calculator functionality, started out with the piecewise. So there was a kind of a side discussion about how do you check your what OS you're using and how do you update your OS. So some links were provided in the chat about going to the website to find out how to get that apps bundle, how to check your OS. Reminder, you can save this chat right now. It'll have all of those special links in it. So save your chat. You can go up to depending on what platform you're using to connect to the WebEx. You have an opportunity to save the chat under File, Save Chat. And it
Oh,
might ask you also when you leave. But there was some great links there.
I think
Updating your
there's probably a
calculator.
link in
Yes.
here to, I
Oh,
didn't want to overtalk you, but
oh,
for
great.
how to update your OS. But of course, it's on the website too, where you get your OS.
Yes, yes. And I checked the OS on mine, and mine is only 5.6, and the latest one from June is 5.8, so I'm a little bit behind.
I think that's a good day now that we've learned what the OS is. It's the latest. We got to get the best and the best. Great job. Yeah.
Right. And for people who haven't updated an operating system lately, maybe a reminder about the apps bundle. We don't just update one thing. They send us a bundle and we update it all at once.
That's right. The great bundle is yeah. Um you don't have you have everything that talks to each other when you do the bundle. When you and it does require a free piece of software called TI Connect. So, and you know what? Stuart and I love to help people. So you email us if you have trouble. And were there any questions? Return us to the original slides. Okay, great.
And I might add,
Valerie, your
if I
question
can,
about test mode is important. You have to get it out of test mode. So if you want to get if your calculator is indicating to you, yeah, I'm in test mode, it's probably uh, not going to it's not going to talk to anything. I hope that helps. Release it from bondage, and then it'll be able to go to the operating table and be upgraded.
That's right. Okay.
and I might add that any feedback, email, I really appreciate any and all emails that come, because this is how I learn and how I can make these
Yeah.
presentations even better if I
We
can hear
do
from
this
you.
for fun. I mean, you should see when we go to conferences, we have our own conference.
Um, Kelly had a great question. Updating your smart view does not work the same way as updating your calculator. Updating your smart view software feels like a software update on your computer. So that's a little bit different location. I think you can still find it from that link that we had there, and it's
And
probably in
yeah,
John's handout as well.
and if you go on the smart view itself under help, there's a right there it says check for upgrades, and it'll lead you to all you have to do.
Okay, we are coming into the final few minutes. You can still send out questions and comments in the chat as we go through. Few more kind of exciting things to do here. I don't know. I'm not going to say we're going to top the excitement that we've already shared today, but we do have a winner tonight in our webinar drawing. So I used my random number generator on my TI-84 CE, and the winner tonight is Ellen from Vernon Township High School in New Jersey. Congratulations, Ellen. You
That
get
is
a TI graphing
fantastic.
calculator. Oh, yay. So, Ellen, you'll be getting an email from somebody at TI, and they'll find out what you'd like to have and where to send it. So, thank you and congratulations, Ellen. Alrighty. There's a link for a certificate of attendance. It's on that slide, but I'll also put it in the chat right now. It'll also be available coming to you in an email since you've registered and attended this. You have an opportunity to get a certificate of attendance. You have an opportunity to get the documents, related documents, not only the slides, but the great documents from John and Stuart. That link is coming again. Uh,
And if you don't mind,
education.ti.com.
Ruth,
There you
I'll
go.
add both links because there's two. And then, cool. Oh,
All
yeah.
right. Yes, lots of good stuff. So, um, it's recorded, and if you remember from the very beginning, it was sit back and watch and enjoy, and then try it out when you have time. View the recording, look at the documents, share information, and remember, John and Stuart have invited you to ask them questions via the email or share comments with you, with them. So thank you. Thank you for sharing that. There's the link to the documents. I did that one, did the certificate of attendance. We did the drawing. At the close of this, there'll be a post-webinar follow-up. When you leave the WebEx platform, it may send you a survey or a link to a survey. Alrighty, about webinars. Wait, guys, what part was this? This was part number 3? And is there a part 4 scheduled?
There is a part 4 scheduled. I think it's November 8th.
November 3rd.
November 3rd. Thank you. Today is the 8th, November 3rd. And we're working on parts 5 and 6. We hope that we'll get to continue this show.
And here's our link to register right there.
All right, great feedback. Parts 5, 6, 7. Keep them coming.
Oh, you guys are great. Thank you very much.
Thank you all so much.
Thank
Remember,
you.
if your platform allows you to save the chat, lots of good stuff, information in that chat we shared tonight. So thank you. Look forward to having you back at our next event. John, Stuart, thank you so much. Lots of amazing things. I can't wait to watch the tape it again and try it out.
Yeah, me too.
Good night,
Thanks
everybody.
again, Ruth.
Good night.
Bye-bye, all.